Valence bond theory starts with the idea of hybridization. So let's, for example, look at carbon. Here's a carbon atom, and the carbon atom here, I'll put this line just to indicate where the carbon atom is. And it starts off with, there's the crosshair, that's the nucleus, 3 p orbitals. And at lower energy, the s orbital. We're going to start localizing the lobes on the one side or the other side. If we consider these two orbitals, for example, we know from sp mixing that they make the hybrid on the left, and the hybrid on the right. This one here, I'm going to call this guy phi 1, this one phi 2. The one I just circled there, is it psi 1 or psi 2? Put it in chat. Remember, all quantum mechanics, it doesn't matter if it's MO theory or not, is going to be using the principle of mixing. So is this new orbital I just circled, this hybrid, psi 1 or psi 2? It is psi 1. And look carefully at this orbital here, psi 1 or psi 2. Put it in chat. Remember, you have to go to minus phi 2. So this is psi 2. We are now mixing, in this case, two orbitals on the same atom, the s and the p. Can an atom make a bond to itself? And the answer is no. So there's none of that constructive or destructive interference to neighboring atoms, lengthening or shortening the wavelength, as in the Hofmann ansatz. Instead, when we mix these two, we are averaging. The sp hybrids are averages of s and p. There are no bonds, and therefore their energies are exactly the average of the s and p, which is why I've drawn them as I've done here, and this is actually an energy scale. So we're not making bonds, we're averaging the s and p, and there they are. We've mixed those two, and having mixed some orbitals, we have to carry over the remaining orbitals. So I'll carry over the remaining orbitals here. This orbital here, and this orbital here. Let me get rid of some of these circles. They're hard to see. We have two higher energy p orbitals, two lower energy sp orbitals, and this is called sp plus p plus p hybridization. In sophomore chemistry, organic chemistry, you will call this sp hybridization. But remember, in sp hybridization, there are two remaining p orbitals. And we will discover that sp plus p plus p is the hybridization used for two different steric numbers, steric number 2 and steric number 6.